So grade 10s, we are looking at module 5, and this module focuses on specifically this activity on the bolt and the nut, which is basically the construction of the bolt and the nut. And just to give you an introduction, this is basically what the nut and the bolt looks like. So these two components are mechanical components which basically go hand in hand, because the nut is something that is turned onto a bolt. And both of them have the shape of a hexagon. As you can see here, there are 6 sides around a nut, and the head part of the bolt has 6 sides as well. And then, of course, the bolt has an additional part, which is the body, and the body is divided into 2 different parts, of which you have a threaded portion where the nut is basically turned on, and you have here a non-threaded portion. Alright, let's look at our activity. So our first subsection of this page focuses on the construction of the nut. Now you will see that there's a straight part at the bottom here and a slightly curvy part at the top. There's a specific way of how we are going to draw this here as well as that part over there. Now if you look at this, the size of a bolt and a nut is normally given in metric meter, which is indicated by an M, which is in front of the value. In this particular instance, if you look on your page, you will find that this nut is an M38. Now, what does the 38 mean? That 38 means it is the size of the hole of the nut. And I want to emphasize it is the size of the hole. And that specific hole is going to be turned onto that bolt that you see here, which also means that if this was a 38 bolt as well, that this body diameter here would be 38 millimeters. So you can use many examples. If you have an M20, the 20 means this opening here, or that size over here, the diameter of the bolt. M12, M14, they all refer to the open section here. You will also find that the nut has a double circle, which would be classified as concentric circles, which is basically inside of the 38 diameter. That double circle refers to the threaded, internal threaded part. Then you will have a third circle, which is on the outside, which is the bigger circle. That diameter is not given to you, but it has to be worked out. Then you will have 6 tangents drawn flat, top and bottom, and at 60 degrees to the side of your circumference of your circle. Those are called tangents, where the circle makes contact with a straight line. This, of course, is your top view, which you are going to start with, and you have your center lines already given to you. This is going to be projected down to become your front view, and you will find that there are what we call 3 faces: face 1, face 2, and face 3. That refers to this slanted face here, and that refers to that slanted face there, and that flat part there is this bigger face that you see here. If you project this over onto your 45-degree line and you project it down, you will find that 2 faces will now be drawn here as a result of the 2 faces that you will see on this side there. Now, when we start drawing, we will have to determine what the outside with the bigger circle is going to be, the diameter of the bigger circle, and that has a specific calculation. And I want to take you through that calculation because now you have to say the following. M38, which is the size of the internal part, times 1.5. Now learners, the 1.5 is a standard dimension. Tomorrow if you have another bolt or nut and it has an M22 perhaps, as an example, you will also times that by 1.5. So 1.5 is a standard calculation which will give you an answer of 57. That 57 means that it is the distance from this side to that side, circumference to circumference. For you to be able to draw the circle, you can either use your circle template, which you have here, but unfortunately the bigger size on your circle template is 36. So you will have to resort to your compass. And for you to be able to draw a 57 diameter, you need to take the 57 divided by 2 so that you can have a radius of 28.5. So we'll round that off to 29. So I'm going to take my ruler and I'm going to measure off 1 short of 30, which is going to be 29. And I'm going to take my compass, anchor that compass on my center point, open up at 29, and draw a circle with a diameter of 57. Following that, I'm going to use my T-square to draw my 2 tangents at the bottom and at the top. And I'm going to use my 60-degree set square, and I can check that that angle there equates to 60 degrees, drawing a tangent like that there. And while I have it in that position, I'm going to follow through, drawing it at the top. I'm going to turn my set square around so that I can reverse my 60 degrees at the top and at the bottom. I have now created 6 corners. And I'm going to use my pencil to highlight those specific sides. Bottom, top, as well as the different sides. I'm now going to add my inside circle, which has a diameter of 38. But because I need a radius, I will have to take the 38 and divide that by 2, which will give me 19. So I'm going to mark 19 from my center to the end of my ruler, which is where the 0 is. And I'm going to use my compass to draw my 38 diameter circle on the inside. And that is basically the opening I'm referring to. I can use my circle and draw it quite hard, draw hard lines so that I have it nice and clear. To be able to add the inside circle, there is a distance between the inside and the outside one. And I need to explain to you how that distance is calculated. For you to be able to determine the threaded distance, you will have to take the diameter, which is 38, which was given to you, and you times that by 0.1. That is the actual calculation. A shorter version of that would be that you can simply take M38, place a decimal in the middle of the 3 and the 8, which now becomes 3.8. And if you round off 3.8, it's going to give you 4 millimeters. That is the same way in saying 0.1 times diameter of 38 will give you 3,8. Instead of doing the calculation, simply just place the comma in the middle of the 3 and the 8, which becomes 3.8, rounded off to 4, and that 4 is going to be the distance from the circle here to the inside, allowing you to show the threaded part there. So I'm going to just mark 4 millimeters to the inside of that 38 diameter circle. Use my compass to draw that inside circle very clearly. Please ensure that you darken that as well. And that now concludes my top view. Learners, now I'm going to project this top view so that I can formulate my front view here. And by doing so, I'm going to take all my points down. These 2 points corresponding, those 2 points corresponding, and that final point on this side. I'm going to create a baseline for my front view, which is going to be there. But now I need to determine what is my height of my nut. And for that, there is a standard calculation as well. I'm going to go back to my M38. And to be able to determine my height, I'm going to say M38, which is merely 38, times 0,8. And M38 times 0,8 gives me 30.4. So we can round that off to 30. I'm going to measure up 30 millimeters from my base. I will draw a line to indicate the height, and you will see that clearly the 3 faces have been formed. That being this face here, which indicate that slanted side, this slanted side by this face over here, and the flat side is my third face, referring to 3 faces of my nut or my bolt. I'm going to highlight the 3 parts very clearly, that being number 1, this being number 2, the middle part, and the third part, which is that part over there. I'm going to project at 60-degree angle, like I've done previously, from the top corner right down, like that as a construction. And let me do that in a different color. And I'm going to turn my 60-degree set square so that I can reverse the option. You are going to find significantly that my point actually meets perfectly in the center. If I am going to project that center point down, it will exactly meet up with the center line, with the 2 lines crossing here. I'm going to project 60-degree lines from the inside top corners as well of my 2 faces. And with that, I created 1, 2, and a third point, which is right here. 1, 2, 3 points. I'm going to use my compass to be able to draw an arc for the middle one by using this point in the center here. I'm going to anchor my compass on that center line, extending the pencil side to the top of my nut, and in that middle part I will darken an arc by repeating the line. I'm going to anchor my compass sharp point on that crossing over there, as you can see, decrease my radius so that it lines up with the top, and I will arc inside that face over there, shaving the top line, and I will repeat the action in this space over here on the other side. I have formulated 3 arcs, as you've seen I've done. The only time you will change angle from 60 to 30 is going to be the following, where I need to draw a short little line from the end touching my top line, and that comes at 30 degrees. I will repeat the process on the other side. A short little line from the outside until the top of my nut. I will then connect the top points of my slanted line, like that there. Those 2 points will be connected. I will darken the baseline and transfer those points down from that slanted line down onto my baseline, like that one there, and I will repeat the action on the other side as well. And that concludes my front view. The next step will be my right view on this side here. I'm firstly going to project my height and my base of my front view across to my right view, as well as all the lines in my top view and my points onto my 45-degree line, like that there, and then I will project them down into the space here where my right view will formulate. Already you can see that I have created the 2 faces by doing that, this being face 1 and that face 2, coming from that slanted side and this slanted side here. The same procedure will be followed here with the 60-degree lines in purple, and that will come from these specific points, that point over there and that point over there. This is my middle, this is my bottom points here. So let me do the same. From the top corners I will project 60-degree lines down both sides, and they will meet in the center, as you can see here. I will also do 60-degree lines from my middle point both sides, and I will repeat that process. I now have created this point over here, that point over there, and that point over there. Similarly, like I've done in my front view, I'm going to take my compass, anchor that point here, and open it up until the top, and arc within that space over there. And I will repeat the process on this side here, arc in that space over there. And then of course, learners, I will not be using this point. This point is only used if I have a middle flat section. I can now draw my base, my top, and my sides. And keep in mind, you will not have slanted sides in my 2-faced right view. So what I am going to do is to darken the bottom, and I'm going to darken the top right through, and I will project dark lines for my 2 sides and my middle section, which basically now concludes my right view. If you go to the opposite side, you will follow the same procedure for the head of the bolt. The only addition to this would be the body of the bolt, which now consists of a threaded portion and a non-threaded portion. Keep in mind that the metric meter is 30, and that 30 refers to the body thickness or the body diameter, and it has to be multiplied by 1.5 to get the size of the outer circle. And remember, it has to be multiplied by 0.1, or you can simply place the decimal in the center, which basically means that you will have a 3 millimeter distance for the threaded section. And that 3 millimeters will apply to this threaded portion here on the side as well, and the bottom. So on the inside of this body part, you will have 3 millimeters in from this side, 3 millimeters in from this side, and 3 millimeters in from the bottom. Watch carefully how this drawing unfolds.